Given that the coefficient of x is q and the coefficient of x squared is 6q, find the value of p and the value of q. Given that the first two terms of f of x are 128 and 36x, find the value of a. Find the value of b. The expansion in ascending powers of x of f of x up to including the term x squared is a minus 232x plus bx squared. Find the value of a, find the value of k, find the value of b.
Hey everyone, George here, and this is part 3 of binomial expansions. Okay, so now things are really getting challenging. I've cherry-picked some questions for you as per usual. Let's go right into it.
Question 1. Find the first three terms in ascending powers of x of the binomial expansion of 1 minus px all to the power of 12, where p is a non-zero constant. Okay, so for question A, what we have to do, 1 minus px to the 12, we expand it using the binomial expansion formula, 1 to the power of 12 plus 12c1 times 1 to the power of 11 multiplied by minus px. And for the third term, we have 12c2 multiplied by 1 to the 10 multiplied by minus px squared. We can go on, but remember we were asked to find the first three terms only. Now to simplify, we've got 1 minus 12px add 66p squared x squared. And that's it. That's our first part of the question. Onwards to question B, it says, given that in the expansion of 1 minus px to the power of 12, the coefficient of x is q and the coefficient of x squared is 6q. Find the value of p and the value of q. Okay. So let's actually first identify our coefficients. We have the coefficient of x, which is minus 12p. That is equal to q as the question tells us. We have the coefficient of x squared, which is 66p squared. The question tells us that that is equal to 6q. From the coefficient of x, we can derive a formula from that. Minus 12p is therefore equal to q. And for the coefficient of x squared, we get the equation 66p squared is equal to 6q, which we can then divide by 11 on both sides and get just simply 11p squared is equal to q. So now looking at our two equations, we can see that they're both equal to q. So the next step on what we would do is to equate them. We can make minus 12p and 11p squared equal to each other. So we have minus 12p equals 11p squared. Now all we have to do is rearrange this to make p the subject and find out what the solution for p is. Next step, I'm going to add 12p to the other side. So now we have 11p squared plus 12p, which is equal to 0. Now a common mistake people do is that they will divide both sides by p. We won't do that. What we would do instead is factorize it almost like a quadratic, and this factorizes to p multiplied by 11p plus 12, which is equal to 0. So that means we have two solutions for p. P is first equal to 0 because of the p outside the brackets, and then we have the 11p plus 12 in the brackets, therefore p is also equal to minus 12 over 11. Now quickly going back to the question, we are told that p is a non-zero constant. Therefore, p is not equal to 0. We will not consider that solution. Therefore, the only other solution to p is minus 12 over 11. And that's it. That's our solution to p. Now we need to find q. Okay, so we can use one of our two equations. We can use minus 12p equals q or 11p squared equals q. I'm going to use minus 12p equals q. It's a simpler equation. So we have minus 12p equals q. I'm going to substitute our value for p into it, which is minus 12 over 11. So now we have minus 12 times minus 12 over 11 equals q. Punching that into the calculator, we get q is equal to 144 over 11, and that's it. We have found our value for q as well now. So these are our two solutions for p and q. Okay, onwards to question 2. Part A asks us, find the first three terms in ascending powers of x of the binomial expansion of 2 minus x over 16 to the power of 9, giving each term in its simplest form. So again, using the binomial equation, we're going to expand this 2 to the power of 9 plus 9c1 times 2 to the 8 times minus x over 16 plus 9c2 times 2 to the 7 times minus x over 16 squared. We can go on, but again, they're asking us to find the first three terms. Simplifying that even more now, 2 to the power of 9 is 512 plus 9c1, which is 9, times 2 to the 8, which is 256, times minus x over 16, plus 9c2, which is 36, times 128, times x squared over 256. This simplified further gives us 512 minus 144x plus 18x squared. And that's it. That is the first three terms in ascending powers of x simplified. Okay, so for part B now. Given that the first two terms in ascending powers of x in the series expansion of f of x are 128 and 36x, find the value of a. Alright, so let's look at a plus bx times 2 minus x over 16 to the power of 9. We have our expansion for that. So we can rewrite it as a plus bx multiplied by 512 minus 144x plus 18x squared. And all we have to do now is expand this. So when we do expand it, we get 512a minus 144ax plus 512bx plus 18ax squared minus 144bx squared plus 18bx cubed. Now the question is only referring to the first two terms, which is all that we have to be concerned about. So this simplified becomes 512a plus, now I'm going to collect the like terms for x. So we have 512bx minus 144ax. That gets simplified to 512b minus 144a times x. Now I can go on, however the question is only referring to the first two terms, which is all that we have to be concerned about. So the first two terms are 128 and 36x respectively. That means that 512a is equal to 128 and 512b minus 144a itself is 36. So finding out what a is now, 512a is equal to 128. That means a is 128 divided by 512, which then gives us just a quarter. So a is 1/4. Going on to question C, we are told to find the value of b. So we know that 512b minus 144a is equal to 36, which is the first thing that we write. Now that we know what a is, we can plug that into the equation. So 512b minus 144 times a quarter is equal to 36. Simplifying that, we get 512b minus 36 equals 36. Therefore, 512b is equal to 72. Dividing by 512, we get b equals 72 over 512, which is the same as 9 over 64. And that is our answer for B. Moving on to question 3, we have find the first three terms in ascending powers of x of the binomial expansion of 2 minus 9x to the power of 4, giving each term in its simplest form. Okay, so this should be a breeze for us right now. We have 2 minus 9x to the power of 4. Expanding that using the binomial equation, we get 2 to the power of 4 plus 4c1 times 2 cubed multiplied by minus 9x plus 4c2 times 2 squared times minus 9x squared. And we'll stop there because we're only looking for the first three terms. Simplifying that, we then get 16 plus 4 times 8 times minus 9x plus 6 times 4 times 81x squared. And finally, we can simplify all of that to 16, take away 288x plus 1944x squared. Okay, so for question B, we are told f of x is equal to 1 plus kx multiplied by 2 minus 9x to the 4, where k is a constant. The expansion in ascending powers of x of f of x up to including the term x squared is a minus 232x plus bx squared, where a and b are constants. So first thing that we need to do is expand 1 plus kx multiplied by 2 minus 9x to the power of 4. We will use our answer from part A to substitute for 2 minus 9x to the power of 4. We can use our expansion for that. So therefore, we will be multiplying 1 plus kx times 16 minus 288x plus 1944x squared. Expanding all of that, we get 16 plus 16kx minus 288x minus 288kx squared plus 1944x squared plus 1944kx cubed. So because of the question we're only working up to the term x squared, we only have to worry up to that point. We can forget about the rest. So now our expression simplifies even further to 16 plus 16k minus 288 all multiplied by x plus 1944 take away 288k all multiplied by x squared. So we are told that our expansion for f of x is in the form a minus 232x plus bx squared. So that means a is the first term, and we see in our expansion that 16 is the first term. For the second term, the coefficient is minus 232k, which matches with 16x minus 288. Then in our third term, the coefficient is b, which matches with the coefficient in our third term, 1944 minus 288k. Therefore, that means that a is equal to 16. So that's the first part sorted out. Next up, we have minus 232x, which is equivalent to 16k minus 288 all times by x. So that means that 16k minus 288 is equal to minus 232. Then to rearrange this equation, we add 288 on both sides. We get 16k is equal to 56. Divide by 16 on both sides. K is 56 over 16, which is the same as 7 over 2. Oh, wait a minute, I just realized that that was the question for question C. Do you see how that just flows naturally? It just progresses to finding the value of K. So that is question C. Now on to question D. So hence find the value of B. Okay. Looking at our third term, we have bx squared, and in our expansion, we got 1944, take away 288k, all multiplied by x squared. So that means we can write it as b being equal to 1944 minus 288k. We now know what k is 7 over 2, so we can plug that right in. B is 1944, take away 288, multiplied by 7 over 2. When we put that in a calculator, b is now equal to 936. That's it. And these questions, pretty much as a standard thing, get as hard as this.
Okay, so we've gone through the hard level questions, and as you can see, there isn't really much of a surprise with it. There won't be any kind of twists and turns. It's pretty standard. When you finally do come across a binomial question in your exam, you should be thinking, great, Edexcel or OCR, whatever exam board that you're using, they're awarding me 3 marks. So if you found today's video helpful, please give us a like, comment, subscribe of course. If you need any tuition, contact me, have my details below. And as always, thank you very much. George out.